Hey guys, in this tutorial I will show you how you can create this fabric shader here. And of course it is completely procedural, so we can change some parameters to affect the pattern and change its look. So yeah, let's start. Okay, so first off, this is a spontaneous tutorial, so excuse me if it is not well structured, and also for my bad English. And also, maybe you might hear some sounds in the background, and this is my dog, so excuse me for that. Okay, so here we have a fresh new Blender file, and let's start by deleting all these objects and add a plane. So we work with a plane object, and now let's organize the view here a little bit. Maybe let's say we don't need the outliner, so let's pull up the 3D view here, and then maybe maximize the shader editor so we have plenty of space here. And right now I don't need all the gizmos, so I disable them. Switch to the top view and also set a viewport to rendered. Okay, so now let's select our plane and add a new material. And here I delete the principled BSDF shader. And to begin, we use the texture coordinate node. And here we can work with the coordinate system we like, generated, UV, object, all of them would work. I choose to work with UV because on the plane they are by default go from 0 to 1 on both axes. So let's take a separate X, Y, and Z node so we can inspect the axes. Here you can see the X and the Y, and Z is 0. And now we want to think about how the fibers are woven. So typically they go in kind of like a sine curve. And for this we can simply take the math node and set it to sine. And right now it doesn't look like anything has changed, but we can visualize it if we, for example, switch the renderer to cycles. And let me set this to GPU quickly. And now we want the displacement to work, so we have a nice visual representation of what the sine curve does. So for this to work, we have to set it to experimental, and in the material we have to set the displacement to displacement, so either displacement and bump or displacement only should work. So right now if I plug this in here, you can see that something happens, but because the displacement is a 3D vector, we need to combine X, Y, and Z, and we only want to displace in the Z direction. Okay, so now let me show you what happens here. You can see that the displacement starts to happen, but right now our plane only consists of 4 vertices, so we need to add a little bit more geometry. So for that, I simply add a subdivision surface modifier, set it to simple, and now you see a curve is appearing. If I add more geometry, the curve gets smoother. But we can simply toggle on adaptive subdivision. And now the subdivision depends on the distance to the camera. So topology is added where it is needed. So this is exactly what we want. So now let me disable all the gizmos again and maybe maximize this window here a little bit. Okay, so now you can see the influence the sine curve has. But let me say we want a higher frequency. So how can we do this? You can do this by multiplying a value before the sine value. And now you can see nicely what happens. And for a full rotation in the range of 0 to 1, we need to multiply the sine value, or the x value, sorry, with 2 pi or simply tau. And now this describes a whole rotation. So yeah, that's exactly what we need for now. So let me simply group this a little bit together. Okay, so now to add more repetitions of this pattern here, or more rotations, can simply take another multiply node, and let me say we want 5 repetitions for now. We have this node here. So maybe we make this accessible with a value node. And here we can control the repetitions. And right now the amplitude is really high. So let me lower it a little bit by taking another multiply node and maybe put in 0.5. So like that. And now we can see that the sine value goes originally from 1 to -1, but let me remap it so it is in the visible range of 0 to 1. And we could do this with a map range node, but we could also do this with a multiply add node, which is in my opinion, a little bit more lightweight. So multiply add node, and by default it does exactly what we need. It multiplies the value by 0.5 and adds 0.5 to it. So now it is remapped. Now let me delete this reroute node here for now and clean this up a little bit. Yeah, okay, so that's a very basic setup. And right now we have to imagine that this here is one fiber. So let me quickly toggle in this right now. So it should be maybe a little bit thinner, but we want to do it all in a shader. So how can we add more fibers to it? So the idea here is to take the y coordinate and displace the fibers based on the y position. So let me show you what I mean. If I, for example, take a multiply node on the y-axis, let me have a look. So let me disable the displacement for now. Move this out of the way. If I now use a fraction node, we can see this repeating pattern here. And now we could do this in multiple ways. And I choose to use the greater than node. And this returns values from 0 to 1, evenly spaced when I set this to 0.5. And now I can offset my sine curve based on these values. So every second row gets a little offset. How can we offset it? So yeah, you might guess it already. Here we have the frequency, and this is our sine curve, and we can simply offset it by adding a value to it. So like that, you can see here what happens. And if I plug this straight in here, you see that it seems that nothing has changed. And this is because the offset is exactly 1, and 1 describes one whole rotation, so we won't see a difference. But if I multiply this value here by 0.5, then it should offset it by half of a rotation. So let me show you what happens. 0.5, not 5. Yeah, here you can see that it starts to begin to look like we want it to look. So let me add the frequency in here. So both of these get scaled simultaneously. And now the next thing I want to do is I want to add a little bit of shading to these fibers here, because right now they are pretty flat. So I want to make them round a little bit. And for this, we can have a look right here. So on our fraction node, we need to divide this by 2 or add a repetition in here. So let me simply multiply the value we have here by 2 and use another fraction node. Oh, let me move this here. And now we have a linear gradient which goes from 0 to 1. And what we could do is we use a float curve node for now. And I will change this in a minute. I will use this just to show you what I want. So like this, maybe we can make a nice little curve. And then I multiply this onto our pattern. So multiply, and we use this. Oops. Yeah, so now it has a little bit of a curvature to it. So let me scale the pattern down a little bit, and for visualization use the displacement again. Yeah, so without the multiplication, it's pretty flat. And with the shading, with the multiplication, it shows some shading. But I don't like to use the float curve because it's not really precise and also a little bit overkill for this. So how can we do this mathematically? Let me delete this here. Now we have this interesting pattern, kind of like, looks like a roof, but yeah, let's do fabric instead. So we can do this by remapping this value we have here first in the range to -1 to 1. So let me, in this case, use the map range node and say -1 to 1. And now we use the absolute, which returns only positive values. And you can see what happens. And if I multiply this onto our pattern, it looks like this, because this value here is in the wrong order. We need to negate it. So we map it, or we simply could use a subtract node and subtract the value from 1. Oh, wrong order, like this. And now we multiply this onto our pattern. So let's have a look. Yeah, it starts to look like we want it. But you can see that it kind of looks spiky. And this is because the interpolation we have created here is linear. And how can we make a curved look? You can simply use the math node and set it to power. And maybe we need to do this before we negate the value. So right here. And now you can see that kind of like a curvature is a curve is appearing. So let me set the exponent to 2. And now we have this nice smooth curve. So yeah. Let me have a look. Okay, this looks nice. So let me quickly add some frames around these. So let me call this shading, and this here we can call placement. Okay, so now we have fibers along the x-axis. So now we want the exact same pattern but in the y direction. And for this, let's simply duplicate all of these nodes here. So without the displacement. So let me simply disable it for now. So all these nodes, and duplicate them. And also I want the same frequency or scaling. So let me connect this to here and also to here. Now let's have a look at this. How can we rotate it? By simply switching X and Y. So now you can see it goes in the opposite direction. And if we now combine these two patterns, so yeah, maybe let's do the maximum method. So this is what we need. Have a look at this. You can see that this interesting pattern here now is appearing. So the problem we have right now is that we need to offset this pattern here along the y-axis by half a rotation. So how can we do this? By simply adding 0.5 to it here. So yeah, like this. And now if you have a look, yeah, we can see that the pattern now looks like we want it to look like. If I visualize it with the displacement, it looks like this. So already looks like a nice weaving pattern. And of course it is all procedural. So we can change the scaling of it. But what I also would like to do is to define the thickness of these fibers. So a way to do this is by changing the shading here. So and right here we have it, and can do this, for example, with the map range node by changing these values here. Let's have a look. So yeah, we can see that these values here define the thickness. But there's a more elegant, more simple way of doing that. And this is simply by multiplying the output we have here with another value. So we take a multiply node. Oh, the auto offset messes things up again. I need to disable this by default. So yeah, so if we multiply this value here, it should define the scaling. So let's have a look. And yeah, so I also want to clamp this value to keep it in a range of 0 to 1. And right here we can define the thickness of the fibers. So I make it accessible with another value. So if I want to create a node group out of all of these, I can remember that I need to create an input here. Now let me put this to 1.6 for now. And I also want to do the same here. So I copy these two nodes and paste them in here. Yeah, now I can scale them both independently. Okay, so now the pattern looks a little bit too uniform, a little bit too perfect in my opinion. So let's say we want to give each fiber a unique color or a unique value. How can we do this? Let's go right here into our displacement. Oh no, I mean the shading. Let's have a look here. Disable the displacement for now. And you can see that kind of like this describes all of these fibers. So each step is one fiber. And how do we create a unique value for them? So first, let me go right after the multiply node here. And instead of a fraction, we're now doing a floor operation. So it rounds the value, and this gives us a unique value. We can see here 0, 1, 2, 3. And if I plug this into a noise node, a white noise texture, we set it to 1 dimension. This gives us a unique value for each fiber. Okay, so we can create a little offset to give it kind of like a seed value, like this. And here we can change it to a pattern we like. So maybe like this. Put a frame around it and yeah, simply call it random. Then I duplicate it. And I do the same on the bottom pattern here. I give it another seed. So maybe like this. And now that we have these two random patterns, we need to mix them. And for this we need a mask between these two patterns. So how can we differentiate between these two patterns? Instead of a maximum, we simply need to do a greater than operation. So here I choose greater than. And now I have this mask between these two. And if I now use a mix node, set this for the factor. And now I use these two values here. It's the wrong order, so maybe like this. Yeah, this looks okay. So let's make this a little bit more compact. And I call this random again. Here we have the main pattern. These are our displacement nodes. And now I can simply multiply my random value to my pattern. And instead of a math multiply node, I use the mixed color node because this has a factor slider which should define the strength of the multiplication. So I set it to multiply. And now you can see that we can create a little bit of randomness. So scale up the pattern a little bit like this. And now this looks way more organic. And Let me quickly create some input values for here so we can define the seed values. And now we are really close to what I want. Let's add the displacement again. And yeah, scale it up a little bit. And here you can see that the different values also describe the height. So yeah, I'm happy with that. And we could also use the color value here and mix them and use color values instead. But yeah, in this tutorial we work grayscale only. And the last thing I want to do now is to add a little bit distortion to this pattern. So if you watch some tutorials of mine, you already know what happens now. So we simply need to distort our coordinates, and we can do this with a noise texture. And now we add this noise to our coordinates. So we simply use a vector math add node. And add this onto our coordinates. So now we have this nice abstract looking pattern, but we don't want it to be so extreme, so we use a scale node and scale it down a little bit. So this describes the strength of the displacement or distortion. And here we can define the frequency. So when we want a pretty high frequency, we need to scale down the scale a little bit here. And you can see that the distortion only happens in one direction, and this is because our color information here is in the range of 0 to 1, and we can simply remap it by subtracting 0.5 from it. So let's set minus 0.5 in here, and now you can see the distortion happens way more naturally. So yeah, let's play with these values here a little bit. So yeah, I'm pretty happy with that. Looks nice and organic. Put a frame around these and call it distortion. And yeah, that's the tutorial for now. You can improve this pattern here, can do many more things to it. But yeah, for this tutorial, this should be it. I will put a link to this file down below. And now some shameless self-promotion. If you want to support me and you want to have a look at the really advanced procedural fabric setup, you can have a look at my Gumroad page. There you can purchase the Trips Fabrics add-on, which I will put a discount down below so you can check it out. And this consists of 7 procedural patterns and also some material presets, a baking setup, and much more. So yeah, check out the link down below with a 30% discount. And I hope you've liked this tutorial, and see you next time.